The HPE Secure Compute Lifecycle offers cradle-to-grave protection across the entire lifecycle of the server. Let's take a look at the journey of the world's most secure industry-standard server. Before the server is even manufactured, HPE is designing in the silicon root of trust. At the fabrication plant where the custom ILO silicon chip is developed, HPE installs a special cryptographic algorithm into the silicon by opening gates and embedding our technology. Think of it as anchoring your firmware into concrete, providing a firm and immutable foundation. When it's time for the system to boot, the server essential firmware will immediately check with the silicon-anchored algorithm to see if it is a match. If anyone has inserted malware, a virus, or compromised code at any point during production, shipping, or within the supply chain, the server will detect a mismatch with the HPE custom silicon. If there is not a match, the compromised code will not run. This authentication measure will protect the server from the factory to the floor in the customer's data center. From the custom silicon fabrication facility, the HPE firmware anchored into the silicon makes its way to the production line in the factory. The HPE silicon root of trust is inserted in the motherboard and the server is assembled. The silicon root of trust protects the firmware during the production process. HPE works closely with our suppliers to ensure security procedures are followed when installing critical components such as hard drives, memory processors, and more. Through special tracking, HPE uses unique anti-interdiction procedures to ensure the exact same components that were ordered are the same authentic and genuine parts that are received and installed in the HPE ProLiant servers. HPE utilizes special anti-counterfeiting technology to ensure virus-infected counterfeit parts are not installed in the server. If customers are concerned with the country of origin of the ProLiant servers, HPE offers public, cybersecure TAA models that are assembled only in countries within the Global Trade Agreement Act. The final step of manufacturing, if requested, is the installation of a chassis intrusion detection device called a hood latch. The hood latch is installed in the ProLiant server before it even leaves the factory. Amazingly, this intrusion detection device will create an ILO audit log alert if the server is ever opened, even if the power is off. As the HPE ProLiant server leaves the factory, it makes its way through multiple shipping, receiving, and distribution facilities on its way to the user. Thanks to the silicon root of trust and the chassis intrusion device, HPE customers can be assured their server will arrive safely and free from any malware or compromised code. After arriving safely at the customer location, the HPE ProLiant server is put into operation. When the server is started, the ILO firmware is the first component to initialize. Over 1 million lines of firmware code run before the operating system is even started. The silicon root of trust acts as an authentication fingerprint, ensuring the server essential firmware has not been compromised. We call this protection boot to business. While the server is operating, if any unwanted action to gain access to the server's firmware occurs, HPE will notify the customer through an ILO audit log alert, which can be received through a SIEM tool like ArcSight. But HPE doesn't stop there. We not only provide runtime firmware validation, but also the unprecedented ability to fully recover firmware to a known good state. In the unlikely event of a security breach, HPE can automatically recover the server essential firmware through the brand new HPE ILO 5 Advanced Premium Security Edition. This new license gives customers the option of recovering to the last known good state of firmware, to the initial factory settings, or customers may choose not to recover, and instead take the server offline for forensic analysis to determine how the breach occurred. HPE is the first server manufacturer to announce support for the new CNSA suite, or Commercial National Security Algorithm. CNSA provides the very highest levels of protection for handling the most sensitive information. Unlike other competitors, HPE provides encryption of data at scale through their smart array controller cards. Rather than managing an encryption key for every drive, HPE stores and manages those keys in the same controller cards. The HPE Smart Array controller cards are qualified with the Italia ESKM device for encryption key management. Of course, protection from cybercrime is not the only security customers need to worry about. They must also be sure to comply with a myriad of new data protection regulations. HPE is helping customers by applying the NIST 853 security controls to a solution stack of servers' networking, storage, operating systems, and software. And with the assistance of HPE Point-Next services, we can provide complete certification with mandates like ISO 27002. At a very minimum, the NIST 853 controls provide a secure baseline, making customers feel comfortable using an ATO, or authority to operate, before the system is even put into operation. Along the HPE secure compute lifecycle, products eventually reach their natural end of life. It is important to properly dispose of equipment and ensure data is securely erased. Erasing data can be accomplished through the HPE Intelligent Provisioning Tool or through the HPE Point-Next services. HPE Point-Next will ensure all data is erased in accordance with NIST guidelines, so the information can never be resurrected, even by the most enterprising hacker. HPE's secure compute lifecycle provides a holistic and comprehensive approach to security. By protecting our HPE solutions from cradle to grave, HPE provides the ultimate security in protection, detection, and recovery technologies from start to finish. HPE's secure compute lifecycle, from cradle to grave protection across the entire portfolio.